When working with an individual value from a normally distributed population, we use the z-score formula x bar minus mu over sigma. When working with a sample or a group and not a single individual, we use the z-score formula x bar minus mu over sigma divided by the square root of n. So if you deal with a single individual, we use the first one. When we deal with a group of people, we use the second one. So let's look at an example. A ski resort in Colorado has a gondola that can carry skiers to the top of a mountain. There is a sign on it that says maximum capacity is 12 people or 2,004 pounds. That capacity will be exceeded if 12 people have weights with a mean weight greater than 167. So just take the maximum capacity of the weight divided by the maximum capacity of people. Men tend to have more weight than women, so the worst case scenario would be 12 skiers that are all men getting onto the gondola at once. And since we're talking about men, we're going to say that men have weights that are normally distributed with a mean of 172 pounds and a standard deviation of 29 pounds. So, find the probability that an individual man is randomly selected and his weight will be greater than 167 pounds. So first off, we need to go in and know what is our mean. Well, our mean is going to be 172, and our standard deviation is going to be 29. So these are the facts of it, and now we can go and pick out the particular x value. So the probability of a randomly selected man having a weight greater than 167, so that's our x bar, and it's going to be greater than 167. Once we have all that, and we know we're dealing with an individual, we use the formula for an individual. So z equals 167 minus 172 divided by 29. Run that through our calculator and we're going to get negative 0.17. And since we want it to be greater than 167 pounds, that means our z-score, we need everything to the right of negative 0.17. We're going to do normal CDF with a lower bound of negative 0.17 and an upper bound of 9999. And since we're using normal CDF, it's just easier to use the calculator, so bring that up. And so we're going to go to second and bars, number 2, normal CDF, and we're going to do negative 0.17, comma 9999, and then enter, and we're going to get negative 0.5675. So our probability is going to be 0.5675. So this is what we would get for a probability if we were trying to find an individually selected man whose mean weight is greater than 167 pounds. Now what if we're trying to find a group of men? This time we're trying to find 12 of them. So let's look at the whole question. And we're going to see the probability that 12 randomly selected men will have a mean weight that is greater than 167 pounds. So everything's the same from the previous question, except this time we have a group of 12 men. So we need to find our mean and standard deviation, which will not change. So our mean is 172. Our standard deviation is 29. Our x bar is still going to be greater than 167, but now we have an n value, which is going to be 12. Now we plug this into the formula for a group. So z equals 167 minus 172 divided by 29 over the square root of 12. And I would recommend doing top and bottom individually so you don't make a mistake. The top is going to be negative 5, whereas the bottom is going to be 8.3716. And when we put that in to our calculator, we're going to get a negative 0.60. So there's our z-score, and again, we need it to be greater than 167, so it needs to be greater than negative 0.60. So everything from negative 0.60 going to the right. So again, normal CDF, lower bound of negative 0.60, and an upper bound of 9999. And again, we're just going to let our calculator do the work for us, so bring it on up. And second vars, normal CDF, so negative 0.60, comma 9999, and we're going to get 0.7257. No, our probability, 0.7257, which is a fairly high probability of getting 12 men with their mean weight greater than 167 pounds. So it's probably going to overload quite often. Now, that's a nice segue into the question where we're going to use that answer. Looking at the results from part B, does the gondola appear to have the correct weight limit? Why or why not? Well, there's many ways you can go about this, but I'll go what I think is the easiest way to explain it. Does the gondola appear to have a correct weight limit? Well, 2,004 pounds is a fairly high limit. I would say that's probably a safe weight limit. So probably a safe weight limit. It's probably fine. Could it be more, but that's not really too worrisome. The worrisome part is the fact that you can exceed 2,000 pounds when you get 12 adults on there, 12 adult men, by a very high probability. So what should probably be done? Well, should probably lower the capacity of riders. Maybe down to like 7 or 8, but the weight limit appears to be safe. I would say that you should probably lower the capacity of riders to make sure that you don't exceed it.